Welcome to Understand the Math. In this video, I'm going to show you how to convert from a rectangular equation to a polar equation. There are two steps that we'll need to follow. The first step is to substitute in x is equal to r cosine theta and or y is equal to r sine theta. The next step is to simplify the equation into one of these four forms. To do this, we may need to use trigonometric identities to simplify the equation. The first equation that we'll look at is x squared plus y squared is equal to 9. This is the equation for a circle of radius 3 centered at the origin. Our first step is to substitute in x is equal to r cosine theta and y is equal to r sine theta. This gives us r cosine theta quantity squared plus r sine theta quantity squared is equal to 9. This is r squared cosine squared theta plus r squared sine squared theta is equal to 9. We see that there's an r squared common to both of the terms, so we can pull that out. And we write it as r squared times cosine squared theta plus sine squared theta is equal to 9. We know from the Pythagorean identity that cosine squared theta plus sine squared theta is equal to 1. So this gives us r squared is equal to 9. There are two solutions to this equation, and they're r is equal to 3 or r is equal to minus 3. R is equal to 3 is used more often because it's nicer to work with a positive number. Our second example is the equation y is equal to 2x plus 1. This is the equation for a line that does not pass through the origin. We'll begin by substituting in x is equal to r cosine theta and y is equal to r sine theta. This gives r sine theta on the left-hand side, and on the right-hand side we have 2 times r cosine theta plus 1. Since we have an r on both sides of the equation, it looks like we can write this equation in the form r is equal to f of theta. To do this, let's pull the r cosine theta from the right-hand side onto the left-hand side. We have r sine theta minus 2r cosine theta is equal to 1. We can then pull out an r, and then we have sine theta minus 2 cosine theta is equal to 1. We want to get the r by itself, so we're going to write this as r is equal to 1 divided by sine theta minus 2 cosine theta. You can see that the polar equation is a lot more complicated than the rectangular equation, which isn't surprising since our equation is a line and that's more easily described in terms of rectangular coordinates. If we go back to our first example, you can see that the polar equation is simpler than the rectangular equation, which makes sense because our equation is a circle, and that's more easily described in terms of polar coordinates. Let's now look at our third example. Our equation is y is equal to 1 over x, and this is called the reciprocal function. We let x is equal to r cosine theta, and y is equal to r sine theta. Let's plug these in. On the left-hand side, we have r sine theta, and on the right-hand side, we have 1 divided by r cosine theta. Let's simplify this by multiplying both sides by r cosine theta. This gives r squared sine theta cosine theta is equal to 1. We can then use an identity to simplify this further. We know that sine 2 theta is equal to 2 sine theta cosine theta. So we can plug in Sin theta cosine theta is equal to sine 2 theta divided by 2, and that's equal to 1. We can then clean this up by multiplying both sides by 2, and we get r squared sine 2 theta is equal to 2. This equation is an example of the form f of r theta is equal to a number.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.